Hi, and welcome to Section 8.2, Similarity. In this section, we're going to identify the characteristics of similar figures. We'll be working on page 336 to 337, numbers 1 through 14 and 18. Before talking about similarity and how it relates to our honors geometry course, it's important to really know what we're talking about. Similar figures have the same shape but different sizes, kind of like a bouncy ball and a baseball. Similar shapes are produced through dilations, which are also enlargements, or reductions. When solving problems involving similarity, we set up a proportion using corresponding pieces, similar to how we would actually match up pieces using congruency. Now, it's important for me to note that similar polygons have all corresponding angles congruent, and all corresponding sides have equal ratios. So kind of like how we matched up with congruency, we matched up sides, same thing is going to happen here. The only difference is that the angles will match up exactly, but the corresponding sides, when we set it up as a fraction, all the fractions should be identical. We also must ask if our figures are similar, if a similarity statement is not written for us. So our first example, we want to determine if the triangles are similar, and if they are, we want to name all the corresponding pieces. So here we go. Now I think the easiest way to decide if triangles are similar is to look for a similarity ratio by matching up those sides. The way I match them up is I find my smallest, and I match it up with my smallest, my medium, and match it up with my medium, and my biggest, and match it up with my biggest, and make sure that they all reduce to give me the same thing. So here we go. We look at the first one. The smallest with the smallest gave me 8 over 4, which reduced to 2 over 1. My medium over my medium, which also reduced to 2 over 1. My biggest over my biggest, which also reduced to 2 over 1. As long as we have all the exact same similarity ratios, we can say yes, my figures are similar. And now we're going to name all of my corresponding parts. So here we go. My smallest side, which was my AB side, was going to be similar to, and the symbol for similarity is actually just that little squiggle from the top of our congruency. AB is going to be similar to DE. Those are my shortest sides. We have BC was similar to EF. Those are my medium sides. And we have AC is similar to DF. Those are my biggest sides. Now, those are my sides, my angles that match up. Angle A is going to be congruent to angle D because of where they're located. Angle A is at the corner where the smallest and biggest side meet, just like angle D. Angle B is going to be congruent to angle E, and angle C is going to be congruent to angle F. They'll have congruent angles and similar sides. For our next example, we're given a similarity statement. So we're told that two triangles are similar to each other. So we want to name all the corresponding pieces based on this statement. We have two options. Option 1 is we can draw out those triangles. Triangle ABC and triangle DEF, and write them in the exact same order, and then match them up. The other way, which is slightly less time consuming, is to just look at the statement. Just like we did with congruencies, we're going to do the same thing matching up our corresponding parts. Let's start with our angles. First, with the first. Angle A is going to be congruent to angle D, and we can see that on the picture as well. Second, with the second. Angle B is going to be congruent to angle E, and on the picture we can see as well. Angle C is congruent to angle F. Second part, our similar sides. The first two should match with the first two. So AB is similar to DE, the last two and last two. BC is similar to EF, first and last with first and last. AC is going to match up with DF. Now in the picture we can see that AB and DE, BC and EF, AC and DF. For our second example, we have a different polygon. In this case, it's a quadrilateral. I have LIND is similar to SAYE. We want to solve for X, Y, and Z. So I want you to take a second and I want you to think about what you're going to do here. Alright, so here we go. The first thing that you should do is notice that we have a similarity statement. The missing pieces are all sides. What I'm going to do first is I'm going to match up my pieces and see what I have. We have LI, which is my first two, which in this case is X, is going to match up with SA. SA is 8. They're similar, so their sides can be written as a ratio. Next, my middle two. My IN is going to match up with my AY. IN is Z. That's going to match up with AY, which is 9. They form a ratio. My last two, my ND is 4, matches up with my YE. YE is 6. And last but not least, my first and last, my LD, which is 10, matches up with my SE, which is Y. So we have a rotated quadrilateral. Now, what you want to do is find the one that has numbers for both the top and bottom of the ratio, and we're going to reduce that. We have 4 over 6, which reduces to 2 over 3. Now, if you forget to reduce that, no big deal. So here we go. What we want to do is we want to take that ratio with numbers for top and bottom and set it equal to every other ratio that we have. If we know that we have similar polygons, we know that all of their sides should reduce to the same fraction. So here we go. I'm going to take that x over 8 and set it equal to 2 over 3. I'm going to take that z over 9 and set it equal to 2 over 3. And I'm going to take that 10 over y and set it equal to 2 over 3. I'm going to cross multiply and solve for both of them. Cross multiply. And when I cross multiply, I end up getting 3x equals 16. Divide both sides by 3. And x is going to be 5 1/3. Next one's cross multiply. That gives me 3z equals 18. Divide both sides by 3. And that leaves me with z equals 6. And our last one, I cross multiply. And I end up with 30 equals 2y. Divide both sides by 2. And we're left with y equals 15. X is 5 1/3. Z is 6. And y is 15. Here's our last example. We're given triangle BAT is similar to triangle DOT. We know the length of OT, BT, TD, and we want to find the value of x. This is going to be our most difficult example that we're going to encounter right now. Press pause, come up with some good ideas, and see if you can solve for x. So here we go. Here's how I would solve it. First and foremost, when I see this picture right here, it doesn't look overly complex, but I do see that it's two pictures that are kind of smooshed together. I'm going to separate them. So the first triangle I'm going to pull out is this bigger one over here on the left. I'm going to label it B, T, and A. I knew BT was 12, but when I think about the full length of AT, I'm taking this piece and this piece. Now, some of us are going to make the mistake of calling that 15x, and you're wrong. Think about that. If x was 3, the length of AT would be 18. How did I get that? By adding it. Now, we don't know x, so we're going to leave side AT as being x plus 15. Now, the second triangle, this rightmost, I'm going to separate it as well. We have ODT, where I know TD is 9, and I know OT is 15. And I'm going to look at my similarity statement. I know that BT is my first and last, just like DT. I'm going to write it as a ratio. BT is 12, DT is 9. Now, my next piece is AT. Those are my last two, just like OT. I'm going to set those up as a ratio as well. AT is x plus 15, and OT is just a plain 15. And now I'm going to cross multiply. If you didn't get it from this point on, why don't you press pause and see what happens. Alright, here we go. When we cross multiply 12 times 15, what's that going to give us? Hopefully we said 180. Now, when I multiply 9 times x times 15, let's go ahead and distribute that out. That's going to end up giving me 9x plus 135. Now let's solve for x by subtracting 135 to both sides. And that gives me 45 equals 9x. Divide both sides by 9, and x is equal to 5. Now, if you want to double check this, plug in that 5 for x, and that lets me know this side right here is 20. So let's look at our similarity statements. We'd have 12 over 9 for one set. Our other ratio would end up being 20 over 15. Let's make sure they reduce to give me the same fraction. 12 over 9 is going to reduce to give me 4 over 3. Both top and bottom are divisible by 3. 20 over 15, they're both divisible by 5. It gives me 4 over 3. They both have the same ratio, so we know that we have similarity. Last but not least, our homework answers. Again, our homework was 1 through 14 and 18. If you have any questions about anything you saw in the video, please make sure you make note of it and ask tomorrow in class. And as always, have a good one.